Hello, everyone. So, as we continue the momentum theory of the rotor dynamics, we can begin the equation that surround and establish the theory. Firstly, by establishing that the velocity surrounding here is UA, and there's a pressure here, which is PA. Also, we can establish that the velocity surrounding here is UB, and the pressure at this point is PB. Also, there will be UC here and PC here. And there will be UD at this section, and there will be PDA at this section. And don't let us forget that there will be axial thrust at this particular section. So there will be thrust impacting backward as the actuator disc rotates. So therefore, using the schematic, we have here today, we can deduce that apparently UB will equals to UC. Don't let us forget that the cross section B and C are close based on our assumption from the momentum theory. So UB will equals to UC. That's equation 1. And that UB, which equals UC, will also be equals to UA plus V1. That is, V1 is the induced velocity, where V1 is the induced velocity. Also, that UD equals UA plus V2, where V2 is induced velocity at D, and V1 is the velocity induced at the section of the rotor, which is BC. Also, that the pressure at A equals the pressure at D. That's another equation. So from the theory, you can deduce that the thrust equals PC minus PB multiplied by the area at BC, which equals to PC minus PB by R squared. So the total thrust, which equals to M UD minus UA, that's equation 1, that's equation 2, that UB equals UC, which is VA plus V1. And this is induced that UD equals UA plus V2, that PD equals PA, this equation 3, this equation 4, and this equation 5. So these are the most important equations for the momentum theory surrounding rotor dynamics. And from here, we can build more larger equations to establish the fundamental theory of this rotor dynamics. Now, by using the Bernoulli theory, half rho V squared plus P equals constant. We can deduce that from the region A to B, which is region 1, if we were to divide the steam tube into part 1 and 2, region A, B, we can deduce that half rho U A squared plus PA equals half rho U B squared plus PB Also region CD. We can deduce using the Bernoulli theory that half rho UC squared plus PC equals half rho UD squared plus PD. So this equation are for the regions. Now from the equation here, we can find the PC. So our PC becomes half rho UD squared plus PD. This one comes to here minus half rho U square C. Also we can find find PB after finding PC. So our PB becomes half rho U A square plus PA minus this one goes to here half rho U square B. And don't let us forget that we should find PC minus PB from this equation. So PC minus PB equals half rho U squared D plus PD minus half rho U squared C minus half rho U A square minus PA plus half rho UB square. Don't let us forget that it was established that PA equals PD. So therefore, PD will cancel, PA will cancel. Also, we have minus P used to square here. And we also have plus plus minus rho ub square and we know that ub that ub from our previous established equation equals uc. So this one cancel and this one cancel. So our established equation become PC minus PB equals half rho UD square minus half rho UA square. And don't let us forget that UD from our previous assumption equals UA plus V2. So we slot it in here. So this eventually becomes half rho UA plus V2 squared minus half rho UA squared, and this will become half rho UA square plus 2 UA V2 plus V2 square minus UA squared. After unfolding the bracket here, it will solve to this. Then from here we can deduce that it becomes half rho 2 UA V2 as this cancel, become 2 V2 plus V2 square and from here we can deduce that it becomes half rho 2 2UA plus V2 is V2. Then the thrust becomes half rho 2UA plus V2 V2 pi r. Let us forget that A here is pi r squared. It's also to be A here. So it becomes pi r squared. So the TR becomes half rho 2UA plus V2 pi r squared. And don't let us forget the time derivative. On both sides. Of equation that says d dt over dt equals dm ud minus ua over dt. So we are finding the time derivative for the whole thrust. And the momentum. So the time becomes dm over dt ud minus ua, which becomes m dot ud minus ua. And if m dot ud minus ua, the bracket, then m dot equals rho a ua, which equals rho ab ub, which also becomes rho ac uc, which also becomes rho AD UD. And for the region A, AB, the mass flow rate equals rho AA UA, which equals rho AB UB. That's for the region AB. And for the region CD, and the mass flow rate equals rho AC UC, which equals rho AD UD. So these are the established region dynamics for this particular equation. Thank you for staying tuned.